In this video, we're going to look at 3 different ways to solve the Pythagorean theorem. Remember that on your test, you're only going to have to be able to solve it one of these 3 ways. So you're going to want to study one of the ways, whichever way makes the most sense to you. So in this one, you're going to take and you're going to demonstrate the area of this large square in 2 different ways. So the first way that you can do it is think of it as the sum of its parts, okay? So you can think of it as this triangle plus this triangle plus this triangle plus this triangle, and then this square, okay? So that's what we're going to do first. So the first thing I'm going to do is I'm going to think of the fact that all 4 of these triangles are the same. This triangle is A times B divided by 2, okay? That's the area formula. And there's 4 of these triangles, okay? So I'm going to take it times 4, okay? And then I'm going to add the area of my square here, c squared, c times c, all right? So there's one way. Now I'm going to have that equal. I'm going to think of the same square in a different way. So I'm going to think of the length times the width, okay? That would be A plus B times A plus B. That's 2 ways to show the area, and they're equal to each other because the area of the square obviously is the same no matter which way you find it. So now I just need to simplify down both sides, okay? So I'm going to take 4 times AB divided by 2. So actually I can think of this as 4 over 1. So I get 4AB over 2 plus C squared equals, and then I'm going to FOIL. I'm going to take A times A plus A times B plus B times A plus B times B, B squared, okay? Simplifying down even more, I'm going to take this 4 divided by 2, it gives me just 2AB plus C squared equals A squared plus A times B is the same thing as B times A, all right? So really this right here, BA, really I can think of this as the same as just an A times a B, all right? So AB plus AB, that gives me 2AB plus B squared. And then what we learned from our daily math on Friday was that 2AB and 2AB cancel out, because if I subtract it from one side, then it'll subtract from the other. So what that leaves me with is that C squared equals A squared plus B squared. And that's the Pythagorean theorem. Okay, next way, President Garfield's proof. Same thing, we're going to show the area of this trapezoid in 2 different ways and use your results to show the Pythagorean theorem. So we're going to show this area 2 different ways. So once again, I'm going to start with showing the area of each of the parts. So this triangle and this triangle plus the area of this triangle right here. So this triangle is AB divided by 2. And once again, there's 2 of those. Plus, this triangle has C times C divided by 2. Okay? That's going to be equal to another way to find the area. Another way to find the area is the formula for the area of a trapezoid. So that formula is 1/2 times the height times B1 plus B2. Okay? Our height is going to be A plus B. Our base 1 is going to be B. Our B2 is going to be A. Remember, the bases are the 2 sides that have different lengths. Okay? So I'm going to just plug in my formula here. I'm going to take 1/2 times the height, A plus B, times, that's my height right here. Highlight that green just so that we don't get confused. This is, whoops, this is my height, okay? And we'll do base 1 plus base 2, okay? We've got our base 1 here, our base 2 here. Okay? All right. So we're going to go ahead and start simplifying all this down. This is like a 2 over 1. Whoops, don't want red. This is like a 2 over 1. Okay, so 2ab divided by 2 plus c squared, c times c, divided by 2 equals 1/2 times, I'm just going to do all this in the parentheses. I'm going to FOIL once again here. So I'm going to get a squared plus 2ab plus b squared. I'm just kind of going all in one step because this is exactly the same FOIL we did in the first problem here. Okay? So let's see. 1/2 is the same as dividing by 2. So instead of multiplying by 1/2, why don't we just go ahead and change this to divide by 2, okay? So now what I notice is that everything is divided by 2, all right? Something that I think I showed you guys in a review a while ago is that if you have every single thing on both sides of the equation divided by 2, it's not going to change the value to eliminate all of those divided by 2. So it's kind of like we're getting rid of it. So we're going to be left with 2ab plus c squared equals a squared plus 2ab plus b squared. Same thing again. The 2ab is going to cancel out on both sides, and I will be left with c squared equals a squared plus b squared. All right? Okay, and the last one, we've got two different shapes or two different ways to show the area of this square right here, okay? So we're going to do this first one exactly like we did on our very first problem, the looking at the square two different ways. So we're going to think of it as the sum of the areas of each of the parts. So we're going to do the triangles, and we're going to do the square, okay? And then down here, we're going to do each individual section. We're going to do this square and this square, okay? And then we're going to do these triangles here, 1, 2, 3, 4. And we're going to set whatever we get for these ones equal to everything we get for this square, because the area of this square is the same as the area of this square. So this is that 4 times AB divided by 2, because the area of one individual triangle is base times height, A times B divided by 2, and there's 4 of those triangles, plus C squared for the area of that green square, equal to the area of all of these. So this area right here of this blue square is A squared, plus the area of the other blue square is B squared, okay? And then the area of this triangle plus this triangle plus this triangle plus this triangle is the same as these 4, all right? So we've got 4 triangles. We've got A times B divided by 2 times 4, okay? If I wanted to write this the same way as the other one, I could do that. Let's move everything over here. Because it doesn't matter what order we multiply things in, okay? And once again, everything can cancel out. That's the same. So these are the same, leaving us with c squared equals a squared plus b squared. Okay? So once again, you're just going to use one of those 3 ways to prove the Pythagorean theorem on your test.